Okay, our conclusion is the conjunction of x and z. So the first thing I'm going to do is look at the remainder of the proof to see where x and z are in this proof. And it's a lot of a's and b's, but I see here's an x and here's a z. I notice that x is the consequent of a conditional. So I'm thinking modus ponens is a rule that allows me to get the consequent on its own line. So it's possible I could get x and z on their own lines and then use the conjunction rule to get this. So that's my end game. If I'm planning to use modus ponens to get x and z on their own line and then conjunction to get my conclusion, my next plan is how do I get the antecedents of the two conditionals here on their own line. The antecedent of the conditional on line 3 is itself a conditional. If A then C. Do I have the conditional if A then C anywhere already? No, I don't, but I do have if A then B and if B then C. So it kind of looks close-ish. But remember, whenever you want a conditional, conditional proof is a good way to get a conditional. And if you're going to start a conditional proof, your assumption will be the antecedent of the conditional you want. That's this whole thing. So you would make the antecedent A. And then you try to derive the consequent, which would be C. The conditional proof is over when you get the consequent that you want. And then the next line would be your conditional. This one is probably easier to see than how do we get this? This is a negated statement. Since we don't already have this negated statement in our premises, and it doesn't look like a case for conditional proof because conditional proof is for when you want a conditional, but what we want is this whole statement, which is a negated statement. IP is a sort of catch-all rule. You could get most things with IP. Yeah, that's probably true. So if you're going to use IP to get this is what you ultimately want, so you could use modus ponens, then you would want to assume the negation of what you actually want. So this is what you want. The negation of that is this, right? So if you assume this and show that it leads to a contradiction, then you can conclude the negation of the thing you assumed. So that's one way to get it. Another thing you could do is, so we've already talked about how to derive x. What we want is z. Whenever you want something, you could try to use indirect proof to get that thing. So you could try to use indirect proof to get z itself. And if you want z, then you would assume the negation of what you want. That would be not z. And if assuming not z allows you to derive a contradiction, then you can ultimately get z with IP. So there's two ways that you might get to z with IP. For what it's worth, bonus note, could you use IP to get x? Given what we have here, indirect proof actually wouldn't be a good strategy to get x. Let's look at what we would do. So if we want x, we would assume not x and show that that leads to a contradiction. If we had not x as our assumption, we could use modus tollens, which would get us the negation of this. But then we'd kind of be stuck with this negation of a conditional. There is a way that you could still get a contradiction. You'd have to do a conditional proof within a subproof, but it's just not that simple. So probably indirect proof isn't your most efficient way to get x, but it is required to get either the antecedent you want, so you can use modus ponens, or to get z itself. Okay, good luck completing the proof on your own.